I will begin by sharing the slides for the lesson. So just give me a minute, I share. Joanne, can kindly confirm that you can see the screen?
Yes, clearly.
Okay. So I'll be taking you through module 3, which is AI, machine learning and data. My name is Nancy Saruni, data analyst and information system auditor. So I can see we are from different industries, which is good. And we are going to see different ways in which data can be collected from the different industries and used in machine learning. So the outline for this module is as follows. There's terminologies, the machine learning process, the different types of machine learning. I believe you did this in module 2, but we'll just do a quick recap of the machine learning types, data sets and data acquisitions, requirements of becoming a machine learning expert, the difference between data science and AI expert, then reference materials, and there's going to be a quiz at the end of the session. So we'll begin by looking at the different terms used in machine learning. The first term is algorithm. I believe the people in technology understands algorithms, so I'm just going to ask one of you to give us a brief understanding of the term algorithm. Feel free to just unmute and give the definition. Anybody, or I pick one person? Richard, please give us a brief understanding of algorithm, and if you have come across that word before.
Oh yeah, to be honest, I've come across all the words that have been displayed on your screens.
Mm-hmm.
Briefly, I won't expound much on algorithms because, as they say, it's just a set of rules and statistical techniques used to learn patterns of the data. A model, we have different types of models. I can just briefly mention a few of the ones I know. So we have regression analysis and classification, and under those two, we have models like the k-nearest neighbors, the support vector machine, random forest, and there are more to that. And with models, we use the data we get from the.
Thank you, Richard. I just wanted you to give us the definition for the algorithm.
Oh, sorry about that. As I said, yeah, there's not much to expound on. As it has been said, it's just a set of rules and statistical techniques used to learn patterns from the data. I don't know how much I can expound on that, but
yeah, that's okay. Thank you. As Richard has said, algorithm is a set of rules and statistical techniques used to learn patterns from data. This is mainly made by the programmers, where they write code in forms of rules that is used to perform a specific function. So the next terminology in machine learning is a model. A model is the main component of machine learning, and it is used to train the machine learning algorithm. So you'll find that once the set of rules have been developed, this set of rules are going to be used to create a model, which is a main component. So a model mostly has an input, which will be the variables that are going to be used to do the prediction. Then the output is going to be the prediction. The other terminology in machine learning is training data. This is data that is used to create the machine learning module. This is where the data comes in contact with machine learning, because the machine cannot learn by itself. You have to give it like some instructions to follow so that it can learn. So we give it the training data so that it can go into the model, train the model, then give a prediction. Then the last terminology is testing data. Testing data is used to evaluate the module. So once you have created the machine learning module, you use the testing data to check the accuracy of your module. Like for example, I create a module of predicting which loan is going to be approved based on the loan variables. For example, your credit score, your repayment behavior and things like that. So it's going to go through the model, then gives a prediction. So testing data will test the accuracy of the model and give a figure and a confidence level for your accuracy. So if you have questions, feel free to interrupt and ask questions. I will move to the next item, which is the machine learning process. The machine learning process involves building a predictive model that can be used to find a solution to a problem.
Sorry, Nancy, sorry, I think there's a question before you proceed from Amanda.
Okay. Amanda, go ahead. Amanda, you can ask the question.
Her voice is down, but she's asking, please explain the set rules. What does that mean exactly?
On the algorithm.
Let's see. Yes.
An algorithm is, okay, I'll give an example, just a simple programming example, where you are supposed to calculate the sum of two figures, that is A plus B. So the rules will be take A and add B and give me the sum. But in this case, it will be written in a programming language. So an algorithm can be as simple as making an addition to as complicated as doing a statistical analysis for you. So that is an example of the rules. Is that clear, Amanda?
Hello.
Hello.
I have a question.
Yes.
When we're talking about the algorithms and the model, you say that the model is defined by the code that is written.
That is the algorithm.
That is the algorithm.
Yes. Then the algorithm creates the model. The model is more of machine learning where it learns by itself. That is actually the machine learning model. I can give an example of, is that clear? Hazel?
Yeah.
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 Okay. Any other question?
I think you may proceed.
Okay. So the machine learning process, there are 6 steps. The first step is you define the objective. This is the objective of the machine learning. Data gathering, preparing the data, data exploration. You build a model, then you evaluate the model, then you make the prediction. So on the first step, which is define the objective of the model, we ask ourselves questions such as, what are we trying to predict? And what are the target features? And what is the input data? So giving an example of predict the occurrence of rain, to answer the first question, what are we trying to predict? That will be the occurrence of rain. The target features, those are the features, the input data that is required for us to predict the occurrence of rain. On the second step, data gathering. So once you have identified what is your objective, the next step is to gather the information that is needed so that we can train the machine learning model and give us a prediction. So we ask ourselves questions such as, what kind of data is required to solve a problem? Is the data available, and where can we get the data? So when we look at the example of predicting the occurrence of rain, you'll find that we require data such as the humidity level, the temperature of that location, the pressure, and even dates. Then this data will be either captured in a tabular format, then it's going to be used to train the model and produce the prediction.
Before you go ahead, Nancy, I have a question for you.
Yes.
The data that you collect from the weather, how do you get it and where do you get it from? For example, if you're to get the humidity level, the temperature, pressure, what tools do you use to get that information, or where do you get it from?
Okay. You can use, for example, for temperature, we can use a thermometer that automatically captures the temperature around the air and records it in a database. So we can use tools, we can do it manually, or we can even use weather forecasting information. Then now we predict, we create the model based on that, then do the prediction. So we can get it from different avenues.
Okay, that is well understood. What other example can we use other than weather?
Weather.
Because the weather would be, maybe you want to create something random. Let's say you want to create a self-driving car, right? To gather data, how would you gather from a self-driving car?
For a self-driving car, okay, that will be, we have gone through the different types of machine learning. So that will be more of reinforcement learning, meaning that it will gather data from its environment. So as it moves, it's going to gather that data quickly and process it, then act immediately. I guess another example that I can use that will clearly bring that out is, for example, is if Facebook wants to do a personalized advertisement to you. So on the data gathering stage, when you log into Facebook and you make a click of an item that you're interested in, Facebook is going to capture that information and store it in a database. Another way they can capture that information is when you perform a search. For example, you are looking for a house. Again, Facebook will capture that information and store it in a database. Is that a better explanation of where to get the data?
Better.
Yeah. Okay. So on step 3, there is data preparation. On this stage, it involves getting rid of inconsistency in the data. And inconsistencies are things like missing values or redundant variables. So most of the time, the data is never in the right format. And that's why there's a lot of demand for data analysts, because data analysts are the people who actually transforms the data in a way that it can be consumed, either by a machine learning module or for making decisions for businesses. So, the activities that can be performed while preparing the data is, for example, removing the missing values or adding the missing values, removing the corrupt data, remove unnecessary data, like for example, in Facebook, where they have collected your searches and things like that. Because of the confidentiality, they cannot display your name. So they will give you an ID and remove your name. Then remove duplicates. This is where you have a data variable or a set that is applying many times. So you need to remove that and have only once, because when you leave it that way and use that data to train your model, it's going to mess up your accuracy, because it's going to give you a higher accuracy than actually what is required. The other task that is on data cleaning is putting data in the correct format. There are different formats. For example, for dates, you can start with date, month, year, or year, month, date. So when data comes in different formats and you're trying to analyze it, you can actually have the wrong conclusion. So not cleaning the data may lead to wrongful computations and predictions. As again, I've mentioned when I was explaining the duplicates. When you have data that is not clean, it's going to give you the wrong output. So it's very important that the data is clean. So data cleaning is the most difficult. This is based on people who do data science and artificial intelligence. Annoying and time consuming, because it takes up about 80% of the time. Any questions on data preparation? Okay, I will proceed to the next step. That is step 4. Step 4 is exploratory data analysis. So once you have the data with you, the machine learning expert or data analyst or data scientist will explore the data to understand the patterns and trends in the data. This means, in the example of Facebook, let's go with that example. It's going to capture information such as the ads you have clicked, your searches, your location, your gender, your age. So at this stage, the data analyst will look at the relationship between the data. So for example, they will look at the relationship between your age and the type of house you're looking for. So then form conclusions based on that. So the output of that can be, for example, people who are between maybe 20 to about 30 years old understanding that that can be a student or somebody who has immediately started in their career, is looking for a 1-bedroom apartment. So that is some of the patterns and trends that can be identified in the data. And that is what is going to be used to create the model and make a prediction. So the next time we are interrogating the model and I give the age of the person, somebody between the age of 20 and 30, the model will interpret that as somebody who is looking for a 1-bedroom apartment. So at this point, all the useful insights are drawn and conclusions between the variables are understood. So it's basically just playing with the data to look for trends and patterns and the relationships between the data. Step 5, this is building a machine learning model. So this is done by a machine learning algorithm. John had mentioned different types of machine learning algorithms, such as linear regression and decision trees. So at this stage, the data is split into 2 parts. That is the training data. We've seen the definition of the training data and the testing data. So I'd like to ask one person to just remind us what training data is.
That's the data that is used to develop the model and ensure that it's working initially.
Yeah, that's right. It is used to train the model. And the testing data is used to evaluate the model. So most of the time, you will find that the training data is more than the testing data. Normally, I use the 80-20 rule, where 80% of the data is training data and 20% is the testing data. So somebody may ask if the training data and the testing data are different. They are the same data, just that you have split it into 2 so that you can have like a control group to check if your model is working. Is that clear?
To me, it is, yes.
Yeah, that's clear. Thank you.
On the last process of machine learning is model evaluation and optimization. So the efficiency of the model is evaluated and any further improvements are made. So this is when you start using the testing data to determine the accuracy. Those of you who have a background with statistics, there is a confidence level that is calculated so that you can see how efficient is your model. Don't worry about that, because even when you're a machine learning expert, you don't have to get into the details of statistics because those calculations have already been created. So all you have to do is just use an already existing algorithm to calculate for you the confidence level. So once you find, for example, you're doing, I'll give you an example of an application that I developed. It was image recognition systems, which recognize different types of diseases for sugarcane. So for the training, for the data that was required there was images of sugarcane diseases from all angles, different camera resolutions, close, far. Then now we use that to train the model. Now to check for the accuracy, you actually go to the farm, you take a picture of a disease, then you check the prediction. Normally, the model will give you the confidence level or the accuracy level. So it will tell you, for example, this is 60% malaria, or this is 90% malaria. So based on that calculation, you can actually adjust your model to give you a closer match. So instead of 60, you try and push the model to give you a 90% match. So that is the whole process of evaluating and optimizing the model. Any questions on the machine learning process?
To me, it was clear.
Okay, on the next step is types of machine learning. I know you had done this before, but we can just go through it. There is a supervised learning, unsupervised learning, and reinforcement learning. So who is going to jog our memory on what is supervised learning, because we've done it before? Catherine? I can see Hazel has unmute. You can go ahead.
Yeah, I wanted to say that supervised we have a non-target and we're training a model to give us a prediction. Maybe when you use the example of people looking for houses, you look for maybe information about where the house is located, how many bedrooms it has, and maybe what floor it is, such things. So you have a non-target that you're training a model to predict what price that house will go for. That is an example of a supervised learning. And then on the unsupervised,
Go ahead.
there isn't any non-past instance when maybe you're looking at what conversations take place through, what kind of conversations happen in maybe in a setting. You'll never know. You don't have a specific kind people are going to talk about. It's just something random.
Okay, thank you, Hazel. It was of supervised learning. Because we had already gone through it, I'll just like to give an explanation with a diagram that is there. The main distinction is that data is provided beforehand and the data is labeled. So when you look at the labeled data, you'll see that every image of Tom has a label on top of it written Tom. So on the training phase, it's going to look at the characteristics of Tom and give it a label. So next time we give it an image of Tom, it will go through the characteristics of Tom, look at the label, and give us an output, which is Tom. Real-life application for supervised learning is a biometric fingerprint that is used on phones, access doors, and even laptops. So in this case, during the registration process, we give a fingerprint sample. So you'll find that you not only give one sample, but you'll give around 5 to 10 or more if you need the accuracy to be better. That information is going to be stored in the reader, and it's going to be labeled. For example, this is the right hand fingerprint that belongs to person A. So the next time I'm going to come and put in my fingerprint, It's going to check on the data and analyze the fingerprint based on the characteristics and display the label, which is give access maybe to this person, give access to this person. So that is a real life example of a supervised learning, machine learning algorithm. The second type is unsupervised learning. On this case, we give training data to the machine, but the data is not labeled. When you look at the image there, you can see the image of Tom and Jerry, but there are no labels to show you this is Tom and this is Jerry. So how does the machine know how to classify these two different items? So it will look at the characteristics of Tom. For example, the shape of the eye, the color, for example, the feet are white, the hands are white, the ears are pointed. Then to look at the characteristics of Jerry and see the ears are pink and the body is color brown. Then it's going to understand the patterns, then discover the output. So it's going to put them into a category. So anytime you give an image of Jerry, it will look at the characteristics and give you the category. Say, like, for example, Jerry belongs to category A. So a real life example of unsupervised learning is Netflix recommendation or Amazon recommendation, any type of recommendation, they use unsupervised learning. In this case, based on your watch history, Netflix will gather information about maybe the documentaries you have watched, the type of series, the type of movies, and put you in a user group. Then based on that group and what other people in that group have watched, it is going to make a recommendation for you. The last type of machine learning type is reinforcement learning. Here an agent is put in an environment and the agent learns to behave in the environment by performing certain actions and observing the rewards which it gets from this action. There's an example of identifying the best routes that is used in self-driving cars. So here there's very minimal data is provided at first. The agent is just put in an unknown environment, and every time it performs an action, it records the action and what was the output. So it's more of a reward and punishment. So when it gets a reward, for example, identify maybe route A will take 5 minutes and B will take 10 minutes, it stores that, and next time it's going to try that unless it gets now to a different environment and start learning. So they have used this in self-driving cars to predict the best route in Google. And they have also used this in space where they put probes on space and it's supposed to learn the environment and react accordingly. So to just check the different types of, the differences in types of machine learning, again, we have seen the definition. On the type of problems for supervised learning, we get regression and classification problems. This is where mostly there's two types of variables, or in some form of, in linear regression, there are two types of variables that you are comparing. For example, every time there is mosquitoes, we get malaria. They also used for classification problems, for example, where you have a group of characteristics, then you label the output based on the characteristics of that item. For unsupervised learning, the type of problems that we try to solve is association and clustering. I've given the example of Netflix recommendation. Another example is, okay, that has been used before is in a supermarket where you try and put items that can be bought together. For example, you can put milk and bread together and see if the likelihood of people to pick bread and milk. So based on the behaviors of different subsets, you cluster them together, then make predictions. On reinforcement learning, the type of problems that we are trying to solve is reward-based and problems where we don't really understand the environment or the environment changes rapidly. So the type of data that is used for supervised learning is labeled data. For unsupervised learning, unlabeled data. And reinforcement that learning, there's no predefined data. So for the training, supervised learning, we use an external supervisor or a teacher because the teacher has to identify the object. On a supervised learning, there's no supervision at all, also on the reinforcement learning. On the approach on supervised learning, we map the label input to the known output. So this is a very easy application of machine learning. On unsupervised learning, we understand the patterns, discover the output. And reinforcement learning, we follow trial and error method. Popular algorithms, supervised learning, we have so many because most and the easiest forms of applying machine learning falls under supervised learning is linear regression, as I explained, where we have two variables, logistic regression, support vector machines, and KNN, which is K nearest neighbor. On unsupervised learning, we have K-means and C-means, and reinforcement learning, we have Q-learning. Okay. Any questions on that section?
No.
Okay, thank you. So we'll move on data sets and data acquisition. There's a question that Joanne had asked, for example, where do we get the data from? Because you see, the data is what is going to make your machine learning algorithm or model accurate. So we can get data using a registration process. An example of this is for biometrics access. For you to know these fingerprints belongs to person A, they have to come and register. Then it's going to be labeled according to that person. We can also get the data from website crawling. There are different tools that are used to just go to the internet and just get all the information. For crawling, most of the time, people use this, for example, in marketing. For example, if I'm looking for all car salespeople in Nairobi, I can actually use a tool, put in the parameters, that is Nairobi, and look for the word car salespeople and phone number. So once I run the tool, it will go to the website and just get all that information for me and put it in a table format. But I like to caution that although the tools are there and they are free, some of them is illegal because you can be sued for capturing that information without the consent of the website providers. I've seen there's somebody in legal here. Maybe they can confirm if that is true. John, please.
John, can you hear us?
John? Okay, maybe we'll get back to that one. The other form.
There's a question, sorry, Nancy, from the chat. Someone is asking, could you provide an example of the tools?
Of the tools, I've forgotten the name, but when you search for web crawlers, you'll get on Google, you'll get a endless list of web crawlers. Another an example that we have here in Kenya is on the classifieds section. That is it Capital? They get it is for example PGME. They can get ads from different websites and display them on their website. So you will see, for example, it is Star, the Star newspaper. You will see an ad for an house. Then when you click on that house, it's going to take you maybe to a different property site. So there they have used a web crawler to gather that information and display it on their site.
Can you hear me now?
Yes, we can hear you, John.
Okay, sorry. So what was the question? Was it about data privacy?
Yes, it's about using a tool to gather information from other people's websites without their consent.
Okay, so again, I'm not a lawyer yet. I'm still in school, so my response is not legal advice or qualified. Just as a disclaimer. So you can mine data from any public source without necessarily asking for permission because it's public information. But when it comes to information that's protected, especially when we start talking about biometric type of information, that's probably protected. And also depends on where you're getting it from, because different jurisdictions, different countries have different data privacy laws and requirements. So you still have to be sensitive to that as far as where you're getting your information from and what the laws are for the country where you are mining the information from, and also the laws of the country where you're importing the data to, because there is definitely a crossover between the two jurisdictions that you, or multiple jurisdictions that you'll be dealing with.
Okay, thank you, John. The other place you can get the data is creating a system that will capture the data for you and store it in a database. In advertising, we have seen them using website cookies. That is when you open a website, it asks you, are you going to accept cookies? Meaning they're going to capture some information about how you're using the website. You can use surveys, where you send surveys to a customer, then they answer the surveys, which goes hand in hand with questionnaires. Looking at the examples that are there on the left, I'll just like to mention the example and where they get the data. For example, Netflix recommendations. It's going to get the data because of how you use the application. So every time you click, open, watch, it's going to capture that information on the background and store it somewhere, then clean it and analyze it. For digital marketing, it captures information on the platform that you're using. So if you're using Instagram, WhatsApp, Google, there are tags that have been put on the background. Every time you make a click, it captures that information. If you view something and you view it for too long, it even measures the time you have viewed a house and you have viewed it for 10 minutes. So it means maybe you're interested in it. It's It's going to capture that information, clean it, store it, then analyze it later. For self-driving cars, because of the nature of this type of machine learning, it will just gather data from its environment. And on the self-driving cars, the processing power that is needed is quite a lot because it needs to process the data quickly and make an action. So I don't know if I've forgotten any where we can get data that is going to be used for machine learning. Okay, I'll continue. And for learning purposes, we can use open source data websites such as Kaggle and DataQuest. You will find different data sets for different industries, and they will already have given you the machine learning objective. So the data set will be presented there. They'll give you the machine learning objective. They will even give you the algorithms that can be used to give you the conclusion. So you can check out those two websites. I've given the link on the reference section where you can train yourself on how to get that data. You clean it. The objective is already there. You put it on a machine learning model, and it's going to give you an output. So we are going to look at the requirements of becoming a machine learning expert. Number one, and the most important requirement is a domain knowledge of your application area. Like machine learning is not standalone. You have to look for an application area. For example, finance, agriculture, legal, medicine. So you need to understand that industry quite well so that you can also answer questions as where to get the information, what is the relationship within the information that you have acquired, and what is your objective. You also need programming experience. There are different types of programming languages that are used in machine learning. The most common is Python, which is very close to the human language, so it's very easy to learn. There's R. It's also very good, but not as popular as Python and Java. You'll also need basic knowledge of probability and statistics. This is mainly used in analyzing the data, checking the relationship between the data, and again, calculating the confidence level of your machine learning model. Then you'll need data mining skills, that is getting information from different sources. Data modeling, that is transforming the information into different forms. An example is where, for example, you need demographic information of people who have, for example, in a population that is, for example, in Kenya, people who earn salaries. So you see, you cannot analyze each salary by itself because everybody earns a different salary. There's that one who earns from, for example, 1 shilling, it can be until 1 million or more than 1 million. So on data modeling stage, you can group them into groups, for example, 0 to 20, 20 to 30, 30 to 40, just to make your analysis better. Then finally is the data analysis. Here you identify the trends, the patterns, the relationships in the data. Then the other requirement is applying the machine learning algorithms and library. The beauty of machine learning is that you don't have to create the algorithms yourself from scratch. There are already existing algorithms, libraries, and some people call it API, that you can just plug, put in your data, and it's going to do the prediction and everything for you. So there are different types of algorithms that are there. I have put examples there. The one that I've used before is TensorFlow. You can go to their website. They offer training on how to use TensorFlow. They'll give you the data to practice, and you can use it in any platform. For example, you can use it for a mobile application, for a web application, for a desktop application. So the algorithms are already there. All you have to do is just have a little programming experience just to do the connection. You don't need a lot of probability and statistics because the formulas and everything has already been inbuilt in the algorithm, in the API. So again, you can check that out and see how machine learning is, and it's very easy. Don't be intimidated by the word machine learning. All you need is a data set, you plug it in, then it gives you the prediction. The difficult part maybe will be fine-tuning the prediction and making sure that you get a higher accuracy level.
Okay, Nancy, there's a question someone is asking, Felix is asking, kindly repeat the data mining concept.
Okay. For the data mining, this is where you get data from different sources. I think the best way to explain this is when I use an example. I'll use an example that I have been involved before. When I was working for an e-commerce site, we were required to make predictions on, for example, which item will sell. So to make this prediction, I had to get data from different sources. So we got data from the database, that is where the e-commerce site stores its information. We got data from customer care. Those are the complaints, the compliments that were received. We got data from surveys. So we used to send out surveys, we get responses, we analyze that. And we also got quantitative data. For example, somebody says, there used to be a common thing where they say people like buying cars from ladies. So we combine all of that information so that now we can transform it in a way that we can use it. So that is the data mining, which involves now getting into all the different sources based on your inputs and putting that data together so that you can now move to the next stage. Maybe I can go further to the data modeling. So once you have that data in one place, we call it the data warehouse, you will transform this data in a way that can be used. So you will combine, you will slice, you will dice all of that information to just form a way that the data can be easily interpreted. In the example of in the e-commerce site, we will group people into locations. You can group people on age group. You can group people on preference. So that is the data modeling stage. So slicing and dicing the data to create, so that it can be analyzed further. Then on data analysis stage, now we look for the relationships in the data. For example, where, for example, people say they prefer buying cars from ladies. So we will test this. Look for cars where ladies, then we check for the description where it was written, previously owned by a lady. Then we check the number of views that was there on that ad. So that is the data analysis. So we see if the word lady was mentioned, if the views went up. So we'll see the data analysis conclusion will be, for example, where there's the name lady, the predictions, the clicks were higher. So the relationship is lady, high views. Or it can be the opposite, lady, low views, or no change. Is that clear?
Felix, was that answered? Maybe you can answer in the chat.
Yeah, that is perfectly answered. Thank you.
Great.
Okay. So we look at what is the difference between a data scientist and an AI expert. Actually, okay, they are quite the same. There's a data scientist, an AI expert, and there's a data analyst. All these terms, they are similar in the way that we use data and we use it to make decisions. But the main difference is for a data scientist, they may or may not use machine learning to reach a conclusion. Remember, the definition of artificial intelligence is where a machine makes a prediction without explicitly being programmed to do so. So for a data scientist, the machine can be programmed explicitly to produce a prediction. So that is the difference. And you look for the AI expert, they mostly use machine learning algorithms and models to use to reach a conclusion. So they'll have to use one of the machine learning types, that is supervised and supervised or reinforcement. They'll have to create a model, and the machine needs to produce the prediction without being programmed. So again, it's because the difference between data scientist and AI expert is on the responsibilities. So the responsibility of a data scientist is to bring in structure to the big data, because data scientists use big data and go through the whole process of mining the data, modeling the data, then analyzing the data. And they mostly have a goal, which is used for decision making. For an AI expert, the responsibility is to build a machine learning algorithm, libraries, or models. We have given examples of the algorithm, libraries, and models, for example, the TensorFlow. So they can either be involved in the data or not, but their main focus is just to create the machine learning model. So that's it on module 3. I'd like to give a brief quiz, but before we do that, I'll be taking in questions for the whole session.
If you have any questions, you can raise your hand, or you can put it on the chat. If you put it on the chats, I'll read it. If you raise your hands, you'll speak about it. Okay. I can see no questions unless someone is typing on chat. Okay, someone has asked comment on model deployment.
So when you're deploying a model, I'll give the example that I had mentioned, where I was involved in predicting image recognition for predicting the type of disease for sugarcane. So it can be deployed on different platforms. That one, we did it on the mobile phone because we need the camera. So the application will be installed on the mobile phone. The farmer will take a picture of a sugarcane disease, and the machine learning model will run on the phone and give a prediction. So that is one example. The other example is I can say the Netflix recommendation, you'll find that the recommendation model runs on the background. Most of the time, it's very seamless, just like the article that was read earlier from Amazon. It's very seamless. You will not even notice all the processes that happen on the background. So the model will run at the background and provide for you a recommendation very fast. So you can deploy it on any platform, and you should also, that's why you need an objective. So when your objective, for example, is identifying if a loan is going to be approved, then you can deploy it on your core banking system, for example, so that once the loan variables are filled, the model is going to run on the background and say approve or reject. So Bill Robinson, is that clear?
Yeah.
Possibly, Nancy, I could give my, not give, maybe could explain my example. If I want to find out about a farmer's pH, or rather information about farmers' land, their soil, so that we could advise them on the kind of crops that they can plant successfully. How do you deploy a model that would actually get into the soil and gather such data? Because what we have currently are drones, and drones are used to predict possibly diseases or climate. They give information from an aerial point of view. But if you want to get deep into roots and give information on, increasing crop yields, what kind of model would you use to deploy on such a project?
First, we'll again start with the data. You need either a sensor placed somewhere, which is going to gather that information. And for the soil, you can use a sensor that has been dug into the soil. So that will collect the information for you. Okay, so let's assume, yeah?
Sorry, Nancy. Let me make it even easier. How about if we use a lawnmower? A digger. You know those, what do you call them? The ones you drive and dig the soil using the machine.
The tractor.
Now tractor, the movable tractors.
Yeah.
Yes,
you can place a sensor on that item that is going to gather the information for you. And if the model has already been developed, you can send that data to, let me just say, a server where the model is hosted or something. It's going to analyze and maybe give you a notification on the condition. For example, if it's soil, if there's something you need to change, it's going to give you all of those recommendations.
Great, thank you.
So I have shared the link to the Google form. It has quizzes. I can still take questions as you open the link and choose the correct answers. Maybe you can confirm if you're able to access the Google form.
Yes, we can. Thank you.
Okay. Okay. I can see the responses are coming in. We have 5 responses. So now we have 10. So I'll give 1 more minute. Okay. Okay, I believe that is everyone. Can see the responses are here. 100% got the first question right. Okay, now 18 correct responses. The third question, the correct answer was data preparation. So 13 got it right. And the last question, most of you got it right.
Sorry, I have a question, Richard.
Yes.
Yeah, there's this, I think it's the second question, the one that's the one asking, training data is used to evaluate the machine learning model, true or false? So I picked false as the answer.
Yes.
Can you advise on that?
Actually, false is the correct answer because, yeah.
Yeah, I don't know why it marked it as a wrong answer for me.
Probably it's the setup of the Google form. Maybe that, yeah, but the correct answer is false.
Okay, thank you.
So I will close the quiz section and move to the reference material. So most of the time, I find it very helpful to use real life examples or simulations. And you can get that from Kaggle, which I had mentioned. They give you the training data, they give you the model, and they show you how to use it. And the good thing is that from this year, you get to earn you earn a certificate, and the course is free. But this is for a short period. So I will urge everyone to just register if you're interested. Then to learn Python, because you need to learn a little bit of Python, not in depth, but just a little bit so that you are able to connect your machine learning model with your data. And you can learn this from datacamp.com. And again, this is free. And you should look for, when you learn in Python, you should look for Python for, Python for data? Because Python can be used to develop many applications, but just specify you want to learn Python for data so that the data can lead you to machine learning. Then lastly is TensorFlow. This is a machine learning library and API. It does the same thing with Kaggle. It gives you the data set, it shows you how to use it, and it provides you with a model. So feel free to join any of those sites or all of them if you have time, and just go through the coursework. So that's it for the module 3. Feel free to contact me if you need pointers on your group work, where to get the data, how to transform it, how to analyze it, how to get the patterns, the trends, and my email address. So thank you. I think I'm going to hand over now to Joanne.
Thank you so much, Nancy. There's someone who's asking if you have a LinkedIn handle. Maybe
yes,
you can share on the chat.
Yes, I